Hey class, Mrs. Anderson here. Today I'm going to go through the notes for 6.2b, multiplying rational expressions. First, let's start with a few review factoring problems. So for a simple trinomial like x squared plus 5x minus 6, I call it simple because the leading coefficient is 1. You know it's going to be x times x to get x squared. So then you just have to find what multiplies to negative 6 but adds up to positive 5. That'd be positive 6 and negative 1. So your factors are going to be x plus 6 and x minus 1. Same thing over here. So what multiplies to positive 2 but adds up to negative 3? That'd be negative 2 and negative 1. So if it multiplies to something positive but adds to a negative, both of your factors will be negative. So x minus 2 and x minus 1. For the third one, this is a monomial where you can take out a common factor. So they both have 3 in common and x. So if you take out a 3x, essentially factoring is the reverse of multiplication. So you're dividing both those terms by 3x. So you'll be left with a 4x plus 3. All right, in the second one, this is a review from 6.2c, I think it was, or A. So you can take out in the bottom, you can take out a 4x from both terms. And then you're left with an x squared plus 12x divided by 4x is 3. And then on the top, I have 4x squared. So I know that that has a 4x I can take out too, because 4x squared can be written as 4x times x. Then they both have 4x in common. So 4x divided by 4x can be simplified. Now you can't simplify any further because this x squared is attached to this plus 3. So x squared plus 3 and x are separate. They're not the same term. So that is as far as you can go on that one. Here, what multiplies to negative 6 but adds up to negative 5? Be negative 6 and positive 1. So this top trinomial factors to x minus 6 and x plus 1. And then the bottom is difference of perfect squares, x squared minus 1. So that's x plus 1 and x minus 1. Then we have two factors, x plus 1 divided by x plus 1 is 1. So that can be simplified. So we're left with x minus 6 over x minus 1. So then example 3 starts the new lesson for multiplying rational expressions. Rational expressions are fractions that have a polynomial divided by another polynomial. Since they are fractions, we use the fraction rules. If you remember, like 2/5 times 3/16. Multiplying fractions, you multiply the numerators and then you multiply the denominator. So it's top times top over bottom times bottom. So you multiply across. So you'd get, and then if you remember back, you can also simplify fractions before you multiply. So like 2 and 16 are both divisible by 2. So I can change the 2 to a 1 and the 16 to an 8. That makes this multiplying easier. So now I have 1 times 3 is 3 and 5 times 8 is 40. So you're going to apply that same idea to multiplying rational expressions. So maybe to make it easier, I'm going to simplify if I can. So I can simplify like the 5 with the 25. 5 goes into 5 once. 5 goes into 25 5 times. And then 9 and 3 are both divisible by 3. So 3 and 1 and 3. I could simplify these x squared over x, but I'm just going to wait and multiply this out. So 1 times 5 on the top is 5 times x squared. And then on the bottom I have 1 times 3 is 3, then x times y. It does simplify one more time because x squared is x times x. And then you have 3 times x times y. So you can take out one more x. So final answer would be 5x over 3y. All right, I'm going to simplify this one by cross-simplifying or simplifying anything I see right away before I multiply across. And then once I multiply across, I'm going to simplify any further if I can. So essentially, we're making this one big fraction. We're going to multiply across the top and across the bottom. I'm going to cross simplify first. So like 2 and 10. 2 divided by 2 is 1, and 10 divided by 2 is 5. So I can simplify that. 6 and 18 are both divisible by 6. So I can divide this by 6 and get 1, and 18 divided by 6 is 3. The only other thing I see right away is x squared divided by x squared is 1. So I'm going to simplify that. There is some more simplifying that you could do, but just to make sure my work doesn't get too messy, I'm going to multiply across now. So 1 times 5 is 5. Then I have x cubed. And then y cubed times y to the 4th is y to the 7th. So when you multiply and the bases are the same, you add the exponents. So you get y to the 7th because that's 3 y's, and then times 4 more, so you have a total of 7. And then on the bottom, 1 times 3 is 3. Y squared times y squared is y to the 4th. And then we can simplify one more time. We can simplify these y's. So I'd get 5x cubed, and then y to the 7th divided by y to the 4th. You're going to have y cubed. So I'm subtracting the exponents. 7 minus 4 is 3 left over 3. If you want to see how that works, you had 7 y's on the top, and then you had 4 y's on the bottom. So 7 take away 4, you have 3 left, and they're in the numerator. So that would be my final answer for that one. Okay, if we're multiplying a little bit more complex rational functions, we're just multiplying across. So essentially, you can make this one big fraction and just say, okay, I have multiplied this across. Then I'm going to simplify each one. So 5x squared minus 45, I can start by taking out a 5. And then I'm going to get x squared minus 9, and times 1, I don't really need to write that. Then I have, oops, I'm sorry, x plus 3, and then 4x minus 12, I can take out a 4, and I'm going to be left with x minus 3. And then x squared minus 9, that's difference of perfect squares, so I can factor that more, x plus 3 and x minus 3. And then on the bottom, I'm going to bring that 4 out front, and then I have an x plus 3 and an x minus 3 as well. So x plus 3 divided by x plus 3 is 1, and x minus 3 divided by x minus 3 is 1. So final answer for this is 5/4. All right. This one, if we make this all one big fraction, we're multiplying, simplify each section. So the first part here, 3x minus 27x cubed, I can take out a 3x. 3x divided by 3x is 1. Then minus 27x cubed divided by 3x is 9x squared. I'll be able to factor that more, but I'm just going to leave it like that for now. Times, now this is a trinomial for this one where a is not equal to 1. So we have to do a little bit of work. So you take your a times your c, which would be 3 times 1, which is 3, and it has to add up to b, which is negative 4. So that's negative 3 and negative 1 that multiply to 3 but add up to 4. I'm going to use the box method. You could just reverse distribute. You know you're going to have a 3x and an x, and then you know you need a negative 4 in your middle terms and a positive 1 on the end. So you can reverse distribute that. There's only one way to get positive 1. So you could figure it out that way, or you can use the box. So it's 3x squared and positive 1, and then in the center you put these numbers in the diagonal. So the negative 3x and the negative 1x give you that negative 4x term in the middle. And then the outside, 3x squared and negative 3x squared, or negative 3x, have a 3x in common. Then 3x times x is 3x squared. Then 3x times negative 3 is negative 3x, and x times negative 1 is negative 1x. So this factors to 3x minus 1 and x, or minus, oh, that's not right. It has to be, sorry, whoops. It has to be through x minus 1. here. So it is x minus 1. I was thinking -3 and -1 don't make +1 in this last term. Okay, so I have the top factored. Now I'm going to factor this bottom one here. Again, it's another trinomial. You have to factor it the same way. So 3 and -1 is -3, and I need it to multiply to -2. So that's -3 times +1. So it's 3x squared and -1 this time, and then -3x and +1x. So 3x squared and 3x have a 3x in common. 3x times x is 3x squared. 3x times -1 gives me the -3x, and x times +1 gives me the 1x. And then just to make sure, 1 times -1 is -1 here, so that's correct. So here I have a 3x plus 1 and an x minus 1. And then I just have a 3x for this one. So simplifying anything that's the same on the top and the bottom, I can take out a 3x right away and a 3x. And then I have a x minus 1 I can reduce. And that's it so far. So now I'm going to factor this one more. Now that's actually difference of perfect squares. It's just backwards kind of. It's going to be 1 minus 3x and 1 plus 3x. And then I still have that 3x minus 1 left on top with it. So that's my numerator. On the denominator, I have a 3x plus 1. Now, 3x plus 1 and 1 plus 3x, these are the same thing. So 3x plus 1 and 1 plus 3x simplify. So now you're left with just these last two. Now this one on the left here, you could rewrite as -3x plus 1 and then times 3x minus 1. So there we go. I think if you multiply that out, I feel like they're conjugates. It might even, like, oh, it doesn't cancel. Okay, so just leave it like that. All right, the last example really requires you to remember a special pattern of factoring. So first I would check if this trinomial factors any further. So 9 times 4 is 36, multiplies to -6. 36 and 6, I can't do that. So this one doesn't factor anymore, that trinomial. So to make it easier though, when you multiply, like say I wanted you to take 1/3 times 8. Remember, anytime you multiply a fraction times a whole number, you can put that whole number over 1 and then take and multiply across the top and the bottom. So you can do the same thing here. You can put this over 1. We've already decided this doesn't factor any further here, so we're just going to try to factor these other ones. X plus 2 doesn't factor either. Now 27x cubed plus 8 is actually sum of cubes. 27 is 3x cubed and 8 is 2 cubed. So you need the sum of cubes formula, which is a cubed plus b cubed equals, it's a plus b, then it's a squared minus ab plus b squared. So this will factor to a plus b will be 3x plus 2. Then a squared will be 3x squared, and 3x squared is 9x squared, minus ab will be 3x times 2, so 6x, and then b squared would be plus 4. So if you factor that bottom piece with this, you'll notice that these two here are now the same. So those will cancel or reduce. So on the top, all I have left is an x plus 2, and on the bottom, I have a 3x plus 2. And remember that you can't cancel the x plus 2 because this is together and 3x plus 2 is all together. So it doesn't reduce any further. It would be different if it was x plus 2 and then 3 times x plus 2. Then you could reduce the x plus 2's. But here the 3 is connected, so 3x plus 2 is not the same thing as x plus 2.